for question 21, you do have to have this memorized. You have to know what mathematically has to be true for something to be continuous. So the point at that x value has to exist. So let me make up a little graph and show you that if this was a and here was my function, if this point doesn't exist, then it's not continuous. There's a break in the graph. So this has to be true for it to be continuous. The other thing is that the limit as x approaches a from the left has to be the same as the limit as x approaches a from the right. So to show you why that's important, just make up a quick example. Let's say it's approaching y value to the left, that's way up here, but then from the right it's approaching a y value way down here. If the limit from the left is not the same as the limit from the right, then your graph is jumping, and if it's jumping, then it's not continuous. It's got a break in the graph. So it has to approach the same number from the left and from the right. And then even if this is true, and even if this is true, it is possible that one other case could happen. So whatever the y value is at that x value needs to be equal to what the limit is approaching. So let's say I'm just trying to show you why it's necessary. So I do that, and here's a point. Well, for this graph, this is not continuous because it's got a hole in the graph. It jumps up here momentarily, just for an instant. So it's not really so much a jump, but there's definitely a break at x equals a. But the first part of continuity is fine. F of a exists. There is a point when x equals a, so that's not messed up. The second part of continuity is fine because the limit from the left is equal to the limit from the right. But for you to not have this break, this point has to be, this point just doesn't need to exist. It has to be plugged in right here. So the y value for that x value, f of a, has to be equal to what it's approaching on the left and the right. So you will probably see this on your test, and you can see from the next questions that you need this to do some justifying. If the point's not there, it's not continuous. If the graph's jumping, it's not continuous. Now you can't just describe it as, hey, it's not continuous because the graph jumps. That's fine to explain it to your friend that way, but that's not a mathematical explanation. The mathematical explanation is it approaches some y value from the left and a different y value from the right. And then even if the point exists, and even if the limit exists, if the point y value is not equal to the limit y value that it approaches, like this, then it's in the wrong spot, and then there would still be a break. So all three of those things have to be true to be continuous.